On the PROXIMA-2A Beamline, a custom-made plate screener named the Cribleur has been designed and built in-house to screen and collect X-ray diffraction data directly from crystals in their crystallization plates at room temperature. Cryocrystallography requires crystals to be fished and frozen. But the physical manipulation while fishing crystals often damages them. Furthermore, crystals usually expand upon freezing, which can destroy their diffraction power. So why not directly collect from their crystallization plates in situ? Scientists typically crystallize their proteins in special plates. This is usually done using liquid dispensing robots such as the Mosquito, which can handle very small volumes as small as 100 nanoliters, which spares the precious protein sample. Crystals in their wells can easily be found using a standard optical microscope. The crystallization plate is slid into a special 3D printed adapter, which can be quickly fabricated for any type of plate or chip. The adapter is screwed onto the metal base, which mounts magnetically onto the Cribleur. This design is easy to use by the scientists and avoids perturbing the fragile crystals. The crystallization experiments with the Cribleur are controlled via a graphical user interface built in-house. Fill in your directory path name and plate name. Select your plate model. Users can easily retrieve the crystals in the plate. The Beamline is equipped with a special on-axis viewer or microscope that allows one to visualize the sample along the X-ray beam axis. Thus, the scientist sees the crystals as the X-rays see them. Click on the drop or well that you wish to inspect, and the Cribleur will move there automatically. Once in place, you can move automatically to a crystal by double-clicking on it. If necessary, you can adjust the front and back light intensities, the focus, and the zoom. After selecting a crystal, centering is done by clicking the desired positions of the OAV microscope image at 3 or more different rotation angles. The small rectangular box in the microscope image represents the position of the X-ray beam. Once the crystal has been centered, the user can choose between types of data collection methods according to the aim of the experiment. One can do rotation scans to collect diffraction images around a centered point, which is also known as the oscillation method. By reducing the spatial constraints, the Cribleur can rotate plates as much as 80 degrees. For each data collection experiment, one needs to set the parameters such as rotation angle, exposure time, X-ray flux transmission, and detector resolution. One can also collect one-shot or single images without any rotation, which are also known as still images. Mesh scans can scan across a rectangular zone up to 1,500 by 1,500 microns square, with steps as small as 5 microns. Other functionalities are available such as X-ray centering, queuing data collections, and processing diffraction images on the fly. Partial datasets can be merged into one dataset using cluster analysis. And the final dataset can be used to determine the crystal structure.